Parallel and perpendicular lines can be seen in a lot of different places in the world. You think about watching a football game on a Sunday and the lines in the field are parallel to each other. They may not look parallel in this picture because of the perspective, right? But they're 5 yards apart everywhere you look. Also, you notice that the sideline would be perpendicular to the yard lines, and that would mean that they would form a 90-degree angle. We think about architecture and building. We look at stairs, you see a lot of perpendicular lines and then parallel lines. So each step should be parallel to each other, and the side of the step should be perpendicular to the top of the step. So we've seen parallel and perpendicular before. We're going to introduce some properties about the angles when you have parallel lines and they're cut by a transversal. So let's go over some of the terminology, the terms first, the vocabulary. Parallel lines are two lines in a plane that never intersect. They both go on forever because they're lines, but they never touch each other, they never cross paths. And the way that you can show that two lines are parallel is you could say line AB is parallel to line CD. This symbol is how you write parallel. It's just like two L's or ones. Perpendicular then means that the lines intersect to form a 90-degree angle. So when we look at these two lines, line M intersects line L and it forms a 90-degree angle. That's what this little box means. That square means that there's 90 degrees right there. So instead of writing the 90, you could just put the little square. And the perpendicular symbol is like an upside down T. So remember what we learned from 5.1, we could write lines using 2 points or could write lines using a lowercase cursive letter. But in this case, line L is perpendicular to line M. So I want you to feel comfortable with those symbols, understand what they mean, and know how to use them. All a transversal is then is just a line that intersects any two or more other lines. So all it does is it's intersecting another line. That transversal can intersect in any way, can form any kind of angles, but it's just intersecting them. So we see that this pink line here touches these lines, and therefore it's a transversal because it's intersecting two or more lines. There's no symbol for transversal, so you don't have to fill that out. When we have parallel lines, we have a unique thing that happens with the angles, and there's properties that exist. Look at this picture of parallel lines, okay? A is parallel to B. So A is parallel to B. And I asked you to just look at the angles. Which angles seem to be congruent? You know vertical angles are congruent. So you know 1 and 3 are congruent. And you know 2 and 4 are congruent. So we can mark those with the little tick marks to show the congruence. What else, though, seems to be congruent? Doesn't it just look like angle 1 is about the same size as angle 5? Well, if you think it does, it is. They are congruent. And angle 3 and angle 7 are the same. And then angle 6 looks to be about the same size as 4 and 2, and so does 8. So you don't ever want to assume, but those do look like they are congruent, and they actually are. This is something that is true for all parallel lines cut by a transversal. So let's go into the different names. You have alternate interior angles, and they are congruent. What that means is they're inside the parallel lines, but they're on opposite sides of the transversal. So your parallel lines are these black lines, okay? We're only looking at the angles inside there, and they're on opposite sides of the transversal. Well, 3 and 6 are both inside the parallel lines, opposite sides of the transversal. They will always be congruent. 4 and 5, same thing. So if I asked you why 3 and 6 were congruent, you could say because they are alternate interior angles. You also have this idea of corresponding angles. Corresponding angles of parallel lines are always congruent. Corresponding angles, what does that mean? Well, remember whenever we talked about similar figures and we talked about maybe you had the height of a flagpole and the shadow on the ground, and then you had the height of a building and its shadow on the ground, and these were basically triangles, and you could write a proportion to solve for a missing length, and you would match up the corresponding parts. The height here corresponds to the height of the building, and the shadow here corresponds to the shadow of the building. Well, that's kind of the same thing over here. Notice that within these parallel lines, x is, at this intersection, x is like northwest. Down here at this intersection, this x is also northwest. These two angles would be congruent. So they're kind of like in the same position. Notice here on these parallel lines, y is northeast from the point. Go down to your other parallel line. This is also northeast, so these two angles would be congruent. Same with w and same with z. So corresponding angles are the angles that lie in the same direction as each other. If you're looking at each intersection, think about directions. That helps me. And the last type of angles that we have are alternate exterior angles. And whenever you have parallel lines, alternate exterior angles are always congruent as well. Notice the difference between the first ones we talked about and the last ones we talked about. They're still on opposite or alternate sides of the transversal, but they're on the outside this time of the parallel lines. So here's your parallel lines. You're not looking on the inside anymore, you're looking on the outside, but they're on opposite sides. So 2 and 1 would be congruent, and angle, 2 and 7 would be congruent, and angle 1 and 8 would be congruent. Again, these angle pairs exist for other lines, but they're only congruent if the lines are parallel. So let's use these properties to find some missing values. Look at your example 1. In the figure, line L is parallel to line M. Find the measures of all the angles. Well, we know right here is 124. How can we find angle 3? What are these to each other? Angle 3 and 124 are vertical angles, so they are congruent, right? So we're going to have the measure of angle 3 being the same as 124. Well, from there you can do a lot of different things, but to start off, let's think about this. I see a line, and these two angles right here form a line, so what do you know about them? They're supplementary, which means to find the measure of angle 1, we would just add it up with 124, and they should equal 180. Once you have that, you can see that the measure of angle 1 is going to be 96 degrees. So the measure of angle 1, I'm sorry, not 96, what am I doing? That's 7, so that's a 56 degrees. 56 degrees is going to be the measure of angle 1. Now let's use some of those properties that we learned. Right here is 56 degrees. I can flip that over to vertical angles. Right here's an intersection. Vertical angles are always congruent, so 2 is 56 degrees. Now use the pairs we just talked about. Okay, 56 is 2. I'm going to clean this up a little bit. 56 is 2, and so is 1, and 3 is 124. Well, what would these two angles be to each other? This one here and this one here. Are they alternate interior or exterior angles? Well, are they on alternate sides of the transversal? This line must be my transversal because it's the one intersecting the parallel lines. And these two angles are on the same side, so they can't be either one of the alternate ones. They're corresponding. From the intersection, they're both kind of northwest, and they're northwest. So those two will be congruent, which means angle 4 is going to be 124 degrees. You could also think about, okay, let's stick with that 124. If this is 124, what type of angle pair is that with 7? Again, ask yourself where it is compared to the transversal. The blue line's my transversal, so they are on alternate sides. They're definitely alternate. Are they inside the parallel lines or outside the parallel lines? Make sure you notice that the inside of the parallel lines is in here. So are they inside? No. They're alternate exterior angles. They are congruent as well. So 7 would be 124. 5 would be what kind of angle pair with angle 2? Well, angle 2 is 56. Angle 5 is over here. Here's your transversal. Those are inside the parallel lines. Opposite sides of the transversal, they're alternate interior angles. Inside the parallel lines, opposite sides of the transversal. Alternate interior angles are the same measure, so this would be 56 degrees. Oops. And then you could also say that 5 and 6 would be congruent because they're vertical. So 6 would also be 56 degrees. So the unique thing about parallel lines is when they're cut by a transversal, you're going to see two angle measures repeating throughout all the angles, which is pretty neat. And let's use that down here in example 2. If line A is parallel to line B, mark all the angles congruent to angle 1 with 1 tick mark and all the angles congruent to angle 2 with 2 tick marks. And what I mean by that is, let's say you have vertical angles. This one is congruent to this one, mark it with a little circle and a little line. And maybe these two are congruent, so you can do 2 lines and a little circle. Mark all the congruent angles down here. Try this one, then press play to go over it. So angle 1, angle 5, angle 7, and angle 3 will always be congruent if the lines are parallel. And then angle 2, angle 4, angle 6, and angle 8 will also be congruent, but they can be a different value because of the different pairs. Notice 2 and 6 are corresponding, 2 and 4 are vertical, 4 and 6 are alternate interior, and 4 and 8 are corresponding. You could also say 2 and 8 are alternate exterior. So there's lots of different ways to think through this. The last example then, I give you 2 sets of parallel lines. So X is parallel to Y, and V is parallel to W. Find all the unknown angles. Start filling in. I like to start with vertical. So this is 68, right across from it will also be 68. Focus on one set of parallel lines first. So I'm going to focus on these ones. What can I fill in with those 68s? Well, I could do corresponding angles. Find some corresponding angles. Here's my transversal. This one corresponds right here. And this one corresponds right here. Then you could transfer that over onto the other set of parallel lines. Focus on these pink ones. If this was my transversal, this 68 would correspond to what over here? Here's your intersection. It's like the top east corner. So from my intersection, I'd go to the top east corner. This would be 68 as well. And then you can transfer that down here. What else is going to be 68? 68 will also be right here. Remember vertical angles, so 68 can reflect across. This is just pretty fun. I think it's pretty neat. Now the last thing you have to do is figure out what the supplementary angle would be so you can figure out the other ones. So what's 180 minus 68? You can fill in that angle everywhere else. So you're going to practice this a little bit more. Practice those names. Make sure you know alternate interior angles, alternate exterior angles, and corresponding angles. Remember vertical angles too, because those are pretty important here. You're going to see then if you have 2 sets of parallel lines intersecting a transversal, all the acute angles are congruent, all the obtuse angles are congruent, and any acute angle is supplementary to any obtuse angle. If the transversal is perpendicular to your parallel lines, then all angles formed will be 90 degrees. So you can practice this.